A random sample of single males and single females aged 21 to 76 was obtained. The sample includes those currently separated, divorced, and widowed. The subjects were given a trait and asked to respond whether the trait was a deal breaker in terms of maintaining the relationship. The results of the survey are provided in the table for the trait talks too much. Is there a significant difference between males and females who consider the trait talks too much a relationship deal breaker? 0.05 level significance. Let's look at our table. Okay, so the males, 141 out of whatever that total is, 545. And then the females, 112 out of 555. Just adding those totals up. So again, let's state HO and HA. So HO is pretty easy. It's always the equality. There is no difference, that the proportion of males and females is the same. Now, am I given a direction here? Are they expecting that males are going to say, or females, that one group is going to say it more than the other or less than the other? No, it just says, is there a difference between them? So we use the not equal to. I'll come back to this in a second. Let me go ahead and press check answer. Now determine the size of each sample. Okay, and we did that a minute ago. So we're going to look at the number of males. We're just going to total these up. So 141 plus 404 is going to be 545. And then females plus the total number of females would be 555. Now you might have a different sample, so check yours out. Okay. Now determine the sample proportions for each. Okay, so let's determine the proportion of males who say that talking too much is a deal breaker. So the number of yeses divided by the total. So we're going to have 141 over 545, round to three places. So 141 over 545 is 0.259. Do the same thing for females. And 112 divided by 555 is 0.202. And I'll be honest, even I've missed rounding before on these. I'll sometimes give it to four places, or I'll just do it too quickly. So it's okay if you miss one due to rounding. If it's in a problem like this, and you should be able to, you should get 2 or 3 chances at it, so check your rounding on these. But if it's the only thing you miss on a multi-part problem, I don't want you to have to do the whole thing again. Let me know, and I can override that. Okay, so because the data are treated as simple random samples, we need to make sure that we have a large enough sample. It's clear that we do. We need at least 10 successes and 10 failures. I obviously do, but we want to actually find out what this number is. It's N times P times 1 minus P. Sorry, P hat times 1 minus P hat for each proportion. So go ahead and do that. Okay, so when I do this for the males, again, 545, N times P hat, which is 0.259, times 1 minus P hat. And I'll get 1, and it says to round to the nearest whole number, so that'd be 105. Which is definitely greater than 10. And do the same thing for the females. And when I put that in, 555 times 0.202 times 1 minus 0.202, I'm going to get 89, rounded to the nearest whole number. And again, all we want to know is make sure this is greater than 10. They usually will be, I'll be honest, in these textbooky type problems, because if it's not, then we can't use the technique that we just learned. We have to use what's called a non-parametric, which we don't learn in this course. Okay, now we can actually run the test. So I'm going to go to Stat, Proportion Stats. We have 2 samples, and we just have summary data. Okay, so it doesn't appear, we don't really care which one is the males and the females. Oh, actually it does. It says subtracting the sample portion of females from the males. So we're going to do P sub hat male minus P sub hat female. So how does StatCrunch have this? 1 minus 2. So that means group 1 needs to be the males. So the number of successes is what? So for the males, it's 141. Divided by the total, which we already found here at 545. Same thing for the females. The number of successes is 112 divided by the total number, 555. Make sure it defaults to this, but always check your HA. HO is always equals. That's why that's fixed. Can't change that. Not equal to. I like doing a p-value plot, so I'm going to click that little button there. And here we go. I'm going to stretch this out a little bit. So there's our z-stat test statistic, and there's our p-value. We're at the 0.05 level significance, so I can tell it's going to be statistically significant. We are more than 2 standard deviations away from the mean. Let's go around 2 places. The test statistic is going to be 2.24. Close out of that. The p-value to 3 places, 0.025. Okay, now for our interpretation, probably the last part. If researchers conducted the study 1,000 independent times, they would expect how many to result in a difference as extreme as the one we just have? So out of 1,000, it'd be 0.025 times 1,000, which is 25. So 25 of those 1,000, we would see a difference this big if in fact there were no difference. And that is less than our alpha level, right? 0.025 is less than alpha level. Didn't see the same for each gender. Okay. So now we just interpreted what the p-value actually means. And now let's determine our conclusion with regard to the hypothesis test. So the p-value is less than the significance level. We are going to reject. So when the p is low, reject HO. And how low is too low? Whatever this alpha level is. And this is always stated before we actually run the study. When you're doing actual studies, you often have to get what's called IRB forms, and you would state all of this in there. So you can't be changing it just so you can have significant results. There is sufficient evidence. When we reject, there is enough evidence to conclude the proportion of males who consider talking too much to be a deal breaker is different than the proportion of females who consider talking too much to be a deal breaker. Now, this is a little formal, right? We can obviously not only different, but we can actually tell that it's more for the males. So you often want to provide additional context when you're actually doing real research. You don't want to just say it's different. We're going to want to know, well, what is that difference? Who is one of them? One of them has to be larger than the other. Which one is it? And by about how much? And so we would often want to run a confidence interval on this to find out what is that difference. So let's go ahead and do that. You're getting this for free. I'm going to go ahead and just do a 95% confidence interval. Press compute. And so here's our difference. We're 95% confident that the male difference is between, and I have a hard time looking at these decimals, so I'm going to convert these to percents, 0.7% to about 11% more on average. So again, when we reject HO, we will often run a confidence interval to determine which one is different and by about how much. So I hope that helps.